Have you ever wondered about the tiny particles that make up everything around us, especially the elusive electron? We're about to dive into the fascinating world of electrons, the microscopic particles that play a huge role in our universe. An electron is a subatomic particle that is found in the shell of an atom. Picture an atom as a miniature solar system, with the nucleus in the center and electrons whizzing around it, much like planets orbiting the sun. But unlike our solar system, an atom is composed of only three types of particles: electrons, protons, and neutrons. Electrons are incredibly small, even when compared to other subatomic particles. But don't let their size fool you. These diminutive particles carry a negative electrical charge that is equal in magnitude to the positive charge of a proton. This balance of charges is crucial for the stability of atoms and, by extension, all matter in the universe. Now, let's talk about the charge of an electron. When we say that an electron has a negative charge, we're saying that it has an excess of negative electric charge. This is why when you rub a balloon on your hair stands up. It's all due to the movement of electrons. The negatively charged electrons are attracted to the positively charged protons in the nucleus of the atom. This attraction keeps the electrons in orbit around the nucleus, much like the gravitational pull of the sun keeps the planets in their orbits. Yet, despite their attraction, electrons and protons don't collide. This is because electrons are constantly moving in their orbits, creating a sort of shield that keeps them from falling into the nucleus. This delicate balance of attraction and repulsion, of movement and force, is what allows atoms to exist and, consequently, for us to exist. So in essence, the electron is a key player in the atomic world, balancing the positive forces and enabling the existence of matter as we know it. Now that we know about electrons, how do they contribute to the phenomenon we know as static electricity? Well, let's dive right in. You see, everything around us is made up of atoms, and these atoms contain electrons. Normally, atoms have an equal number of positive and negative charges, but sometimes they can lose or gain electrons, creating an imbalance. This imbalance of charges is what we call an electrical charge. Imagine rubbing a balloon against your hair. You're transferring electrons from your hair to the balloon, and since electrons carry a negative charge, your hair becomes positively charged and the balloon negatively charged. What happens next? Your hair strands repel each other and stand up, while the balloon sticks to your hair or to the wall. These are everyday examples of static electricity in action. That, my dear viewers, is the power of electrons at play, causing what we call static electricity. Ever thought about why some materials can carry electricity while others can't? Let's delve into the world of conductors and insulators. Our main players in this game of electricity are none other than the electrons. You see, atoms, which make up all matter, consist of particles called protons, neutrons, and electrons. Protons and neutrons sit tight in the nucleus at the center, but electrons, they love to move around. This movement of electrons is what we call electricity. Now, not all materials let their electrons move freely. Some hold onto them tightly, while others are more than happy to let them loose. This is where the concept of conductors and insulators comes in. Conductors are materials that allow electrons to flow through them easily. Think of a bustling city with wide-open roads where cars can zip around freely. That's what it's like for electrons in a conductor. Metals like copper, silver, and gold are great conductors, which is why they're often used in wires and electrical components. On the other side of the spectrum, we have insulators. These are materials that resist the flow of electrons. Imagine a busy city, but with narrow, crowded streets where movement is slow and difficult. That's the life of an electron in an insulator. Rubber, glass, and plastic are some examples of good insulators. They're used in things like the protective coating around wires to prevent unwanted flow of electricity. So when you flip a switch to turn on a light, you're creating a path for electrons to flow from the power source through the conducting wires to the light bulb and back again. But if there's an insulator in the way, the electrons can't pass and the light stays off. In essence, the flow of electricity is a grand journey for electrons, guided by the landscapes of conductors and insulators. And it's this very journey that powers our world, from the smallest LED to the mightiest power station. So, whether electricity can flow or not, it all comes down to the movement of our tiny friends, the electrons. What makes a bulb glow or a fan spin when switched on? The answer lies in the intricate pathways of an electric circuit. Picture this. You're at home, you flip a switch, and voila, your room is illuminated. But have you ever wondered what's happening behind the scenes? It all comes down to the magic of electric circuits. An electric circuit is like a busy highway, but instead of cars, it's buzzing with electrons. These electrons move around the circuit, carrying energy from the power source to the devices that need it. And just like on a highway, they need a complete path to travel on. That's where the battery, or cell, comes into play. Think of the battery as the engine that drives the electrons. It provides the push that gets them moving. One end of the battery, the positive terminal, is where the journey begins. The electrons, eager to escape, rush out and into the circuit. They zip through wires, powering up devices like your light bulb or fan along the way. Finally, they reach the other end of the battery, the negative terminal, and the journey begins anew. But how do we make sense of all this when we're looking at a circuit diagram? Well, that's where conventional circuit symbols come into play. These symbols are a universal language used by scientists and engineers around the world to represent different components of a circuit. For instance, a simple line represents a wire, while a circle with a cross inside it symbolizes a bulb. The battery, our engine, is depicted as a series of long and short lines. Even though these symbols might look simple, they tell a complex story. They show us how the components of a circuit are arranged and how current flows, allowing us to predict what will happen when we flip that switch. Just like a well-oiled machine, every component of a circuit plays a crucial role in ensuring the smooth flow of electricity, with the electron being the star performer. We've journeyed through the atomic world and explored the role of electrons in electricity. Let's quickly recap. We've seen how the humble electron sits within its atomic home, sparking the phenomenon of static electricity. We discovered the fascinating flow of electricity around a circuit and distinguished between conductors and insulators. We also delved into the generation of electricity in cells and the arrangement and current flow in a circuit. So, the next time you switch on a light or feel a static shock, remember the tiny, mighty electron that makes it all possible.